Okay, so let's look at, for the last few minutes of the class, let's look at some examples. Let's look at, oop, let me get some space here. Okay, so we have a six-sided dice. So we have the sample space. Being 1, 2, 3, 4, 5, 6, the different number of which face, the number of dots on the face that shows turn up. And in the event E, and let's let the event, this event E be the event that E is less than 4, which is going to be 1, 2, and 3. Okay. The event that the face showing is less than 4. So what are the following probabilities? Well, what's the probability of this event? E. Oh, what am I doing? I'm sorry about that. This is the event. I let me go and actually go back and fix this. Okay, because I didn't read the problem, which is obviously a problem. EE makes sense. It's the number of faces showing that is even. This is 2, 4, 6. And then we have a second event, E less than 4, which is going to be 1, 2, and 3. Okay. Now, that makes sense of the notation that E sub B is the even outcomes, and E less than 4 is the event that the face is showing is less than 4. Okay, so now the following probabilities that we want to calculate are, what is the probability of an even face showing? Okay, so now I'm going to pause the recording, give you a chance. Okay, so this non-conditional probability here is just going to be the number of outcomes in E, which is 3, divided by the number of outcomes in the sample space, which is 6. So that's going to be 1/2. What you expect, if there's 3 even faces, 3 odd faces. Half the time it's going to be even, half the time it's going to be odd. So the probability is 1/2. Okay, then the next question was, what's the probability that it is less than 4? So take a moment and write that down, and then raise your Zoom hand when. Oh, I actually was not paused. So let me repeat. I'm sorry, I have to repeat that. So we have here the probability it's less than, probably that the event is less than 4 is 3 over 6. 3 items over 6 is 1/2. Now let's look at item 3, which is the probability that conditional probability that we have an even, that the outcome is even, given that it's less than 4. And okay, so we're almost at the end of the hour. So let's look. So the probability that it's even, given that it's less than 4, is this yes? And someone commented that the answer is going to be 1/3, because you take the intersection here of the even with the less than 4. It's the intersection of these two sets, and the only one in common is 2. So this is 1. So the only outcome that's the same as a 2, but it's over the number in 4, which is 3. So the probability that's even, given that it's less than 4, is 1/3. Now that's sort of mysterious. I mean, it's not mysterious if you look at the sets, but if you think, well, the probability it's even is 1/2, the probability it's even, it's less than 4 is 1/2, but then somehow the conditional probability is 1/3 of the time if you know it's 1/4. That, because basically what you're saying is, if you know it's 1/4, it's equally likely to be 1, 2, or 3. Well, the even one then is just this 2, so that's 1 out of the 3 choices. So it makes sense. That's why this definition makes sense. Okay, and I think then that that completes problem 10 here, but we're really out of time because it's 10:49. So I will put these recordings up on Piazza as I did last week's one, and it turns out there is some question. I was originally going to be back next week, and there's some question of whether I will be able to do that. So it may be, I'll put up a notice, but it may be that the classes next week will also have to be, in-person classes have to be canceled, and I'll have to put up recordings this way for um, next Tuesday and possibly next Thursday. I'll put up a notice as soon as I know what's going to happen. But I'll definitely be back by the latest next Saturday. So I'll definitely be back after that. So anyway, are there any questions about? Feel free to head off if you're here remotely, or if you were listening in. Okay, yeah, wherever you are, feel free to head off unless you have questions.